All right, guys, today we're going to be graphing some real-life quadratic word problems. So graph each of the following equations over the given domain, then answer the questions that follow. During halftime on a basketball game, a slingshot launches t-shirts at the crowd. The equation h equals negative 16t squared plus 72t plus 5 gives the t-shirt's height h in feet after t seconds. Graph the equation over the domain 0 to 5. What is the maximum height the t-shirts will reach? All right, so we're going to pull up the equation here. So we have y equals negative 16, and we can use x instead of t, x squared plus 72x plus 5, and we pull up the table. And from there, we want to look to see if we can find the vertex, but it also tells us to graph it from 0 to 5. So we can start at 0 and graph to 5. So 0 is at 5. Let's think about this. We need to get as high as, before we do that, as high as 85. So we need to break up the scale first. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 boxes. To get to 85, I could go by 5s because that would make it 90. So I'm going to do 10, 20, 30, 40, 50, 60, 70, 80, and 90. Keep in mind that this is the height of the t-shirts. And that this is the seconds that it's been launched, seconds after launch. All right, so we can leave that seconds. If we wanted to, we could spread it out a little bit and do 1, 2, 3, 4, 5. Might as well use the space and spread it out. All right, so 0 is at 5. Change up my color, which is here. Then 2 is at 85. Oh, no, 1 is at 61. Let's do that one first. 2 is at 85. 3 is at 77. Notice we somehow skipped the vertex, which is going to make it look a little awkward. We can narrow it down and find the vertex shortly. 4 is at 37. And 5 is at negative 35. Which is going to be way down here. Okay, so that doesn't really make sense because you wouldn't have negative feet from a launch of t-shirts, but we want to put it there so you see the whole launch. All right, so I'm going to narrow this down so we can see if we can actually find that real vertex. Go back to second and table set. Let's change this to 0.5 and see if that helps us out. Second window. And then we at least see that the 85s are at 2 and 2.5. So that means the vertex is going to be somewhere between them. Okay, so even though we didn't see it right away, you want to try to make it look symmetric. So we're going to now draw this line up and down to our negative 35. So that graph from 0 to the point where it hits the x-axis, where that root is there, that is the path of the t-shirt being launched. All right, so what is the maximum height the t-shirt will reach is what we have to answer here. And we have to think about the vertex in order to get that. So the vertex, again, would be between 2 and 2.5. So we can't assume it's 85. So we actually have to break this down further. Let's change it to 0.25. And now, I didn't see it. Oh, there it is. It's between the two 85s, so it's at exactly 86. Okay, so how high will the t-shirts reach? We can answer with 86 feet. So again, you can't make it up. You have to actually find the vertex to find the correct answer. And sometimes they say, well, how many seconds have passed? So for it to reach its maximum height, it had to travel for 2.25 seconds to get to 86 feet. All right, let's try the next example. The height h in feet of a small rocket t seconds after it is launched is given by the equation h equals negative 16 t squared plus 128t. Graph the path of the rocket from start to finish. Label the graph fully. And then we're going to answer how long is it in the air and how high does it reach before starting to descend. All right, so I might get a little dizzy graphing this because there's some tiny, tiny boxes going on here. But we have to remember again that this is time. And I think it says seconds. Yep. And this is height. And it does tell us feet. So I'm going to write feet next to it. All right, so let's pull up that table. That negative 16x squared can stay. And we want to put in plus 128t or x. I'm going to delete the 5, pull up the table. All right, so now I want to change my table setting again. Let's go up by starting at 0 and go up by 1 for now. If we have to change that later, we can. All right. Ooh, right away, we see the whole path 0 to 0, or 0 to 8, which gives us 0 to 0 for the range. And we see our vertex at 4 and 256, which means we have to go up as high as 256. So we have to break this down so that we can fit that 256 in there. So if we do 10s, I think that might be too small. But if we do 20s, it should possibly fit. Actually, maybe 10s would work. Let's do 10, 20, 40, 50, 10, 20, 30. I'm just going to write the 20s. So 20, 40, 60, 80, 100, 120, 140, 150, 160, 180, 200, 220. Okay, so there's probably a better way to break it down, but being that we are going to see so much of this, I'll do it that way. And then, oh, we have to go a little bit further actually. So we got to get to 256. So at 180, that's the 200, 220, and then this one could be 240. And we'll go to one more for 260. All right, makes sense there. Okay, so now we're going to graph those points as carefully and neatly as we possibly can, keeping in mind that this should be symmetric. So we have our 0, 0 way at the bottom. And since we're going to 8, we could probably break this up. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, just to spread out our graph a little bit. 1 is going to be at 112. So 100 is here. 110 would be halfway in between. So 112 is going to be about here. I think my 100 is written up a little bit high, but you get the point. Hopefully yours is very, very close. Okay, then 192, 2 and 192. Well, if that's 180, 190 would be between 180 and 200. So about here. Then 3 and 240. Then 4 and 256. Underneath the 260. Then back down and symmetrical. So 5 is that 240 again. 6 is the 192 again, which is about there. And 7 is the 112 again, about there. And 8 is back at 0. So we have modeled the whole launch of the rocket. And again, because we saw the vertex, our points should be perfectly lined up and symmetric with each other if we were to draw a line through the axis of symmetry. Okay, so now we can answer those questions. How long is the ball in the air? We can say 8 seconds. okay, because that's modeled by our x-axis. And how high does it reach before starting to descend? Well, that's at the vertex here. This is our maximum height. And the height is, again, at 256 feet. So we can say 256 feet. Done. Okay, so that is a model regions question. We've seen some of those show up on the regions before that are a lot more challenging. You got to take your time and graph it very carefully. All right, so I believe you guys are on your own. Yep, you are. So you're going to try the next one. If there are any more on your own, I'll be checking in. Be careful while you're going over those exit tickets that you're answering them correctly.